Hello, my name is Greg, and in this video, I'll be giving a brief overview and demonstration on Microsoft Windows TCP/IP command line tools, Tracert and Ping. The data returned from running TCP/IP tools, Ping and Tracert, can help PC technicians troubleshoot common network connectivity issues and internet access. Be on the lookout for future videos on TCP/IP tools, netstat, ipconfig, and nslookup. Tracert is another Unix program that was designed to display the path that TCP/IP packets take to their final destination, called traceroute. Called traceroute in Unix, in Windows 7, it's simply implemented as tracert.exe. Because of the nature of the IP routing, traceroute is another Unix program that was designed to display the path that TCP/IP packets take to their final destination, called traceroute in Linux. In Windows 7, it is implemented as tracert.exe. Because of the nature of IP routing, the path from a packet source to its destination on another network can change from minute to minute, especially on the internet. Tracert.exe displays a list of the routers that are currently forwarding packets to a particular destination. Tracert.exe is a variation on ping.exe. The program uses ICMP echo requests and echo reply messages just like ping, but it modifies the messages by changing the value of the TTL field in the IP header. The values in the TTL field prevent packets from getting caught in router loops that keep them circulating endlessly around the network. On a Windows 7 computer, the default value for the TTL field is relatively high, 128. Each time a packet passes from one network to another, the router connecting the networks reduces the TTL value by 1. If the TTL value ever reaches 0, the router processing the packet discards it and transmits an ICMP error message back to the original sender. Tracert.exe works by modifying the TTL value in the successive ping.exe packets that it transmits to a target computer. When you run tracert.exe from the command prompt with a target parameter, the program generates its first set of echo request messages with TTL value of 1. When the messages arrive at the first router on their path to the destination, the router decrements the TTL value to 0, discards the packets, and reports the errors to the sender. The error message contains the router's address, which Tracert displays as the first hop in the path to the destination. Tracert.exe's second set of echo request messages use a TTL value of 2, causing the second router on the path to discard the packets and generate error messages. The echo request message in the third set have a TTL value of 3, and so on. Each set of packets travel one hop farther than the previous set before causing a router to return error messages to the source. The list of the routers displayed by the program as the path to the destination is the result of these error messages. The following is an example of a tracert.exe display. So if you wanted to trace a route to a particular website, you would just go to the command prompt, and you would type, you can use ping, for example, and we're going to see how similar ping and tracert is. Ping, let's say Google, and it would do the hops. And it's telling you that this one is the destination address with 32 bytes of data. So request timed out, it's timing out. 4 packets was sent, 0 was received, 4 lost, 100% lost. So actually it's not reaching there, but I should have internet access. Well, I do have internet access. Now we can do tracert for the same thing. So the tracert command, which is the topic we were discussing here, tracing route to google.com. So most of it is timing out. Each of the hops contains the elapsed times between the transmission and reception of 3 sets of echo requests and echo reply packets. Ping.exe simply tells you whether 2 TCP/IP systems are having trouble communicating. It can't pinpoint the location of the problem. A failure to contact a remote computer could be due to a problem in your workstation, in the remote computer, or in any of the routers in between. Tracert can tell you how far your packets are going before they run into the problem. Because the configuration of the internet is constantly changing, there is no guarantee that the route displayed by Tracert is completely accurate. The ICMP messages that execute each step of the Tracert process could conceivably be taking different routes to the same destination, resulting in the display of a composite route between 2 points that does not actually exist. There is also no way of knowing what path the packets are taking as they return to the source. In addition, routers typically deprioritize ICMP processing in favor of packets forwarding and other more critical routers' tasks. When a router is busy, it might delay the processing of an echo request or echo reply packet. The resultant latency numbers will be higher than the delay experienced by actual data packets crossing the network.
What's displayed in this screen is the output of the Tracert tool in Microsoft Windows command line interface. That wraps up this video on a brief overview and demonstration of Microsoft Windows TCP/IP command line tools, Tracert and Ping.